Hexadecimal. It's a big word that really means hex and decimal. Hex means 6, decimal means 10, 6 and 10, or a fancy way to say base 16. So before we get too deep into the ones and zeros, you'll see that it's very error prone to communicate numbers like 4D2 in hex would be 0100, 1101, 0010. There's better notation. Just like talking about millions and billions, we say 1 million. We don't say 1, 000, 000. I mean, nobody speaks that way. We have nice handles for big numbers. And hexadecimal is just a nice way to handle big numbers. So we can speak of a byte instead of 8 ones and zeros. We can just use 2 digits, and those 2 digits become 00 through FF. Yes, FF. We have to have digits after 9. So instead of speaking as a byte of 8 ones and zeros, we can speak of a hexadecimal number that has the same value with just 2 digits. And those digits, as you'll see, are between 0 and 9, and after 9, we use the letters A through F. In binary, we can take our hexadecimal digit apart because it is 2 digits. So 1 digit represents 4 bits, or a nibble. A nibble is 4 bits represented by 1 digit. And you can see 0 through 7, 8, and 9 are very obvious. But what do we do when we have 10, 11, 12, 13, 14, and 15? We can't use 1, 0 because that's 2 digits and we need a column. We need a glyph, a symbol, one simple symbol to represent 10 through 15. So we need something new. Now, many people argued about what these letters or different fonts, even people were designing different fonts for these. Today we use 0 through 9 and A, B, C, D, E, F for 10, 11, 12, 13, 14, and 15. So that's why we have the digits 0 through F that make up a hexadecimal number. But hexadecimal goes back to the 1770s in France. Today A through F seems very obvious. When everything's done and the solution is solved, it seems, of course, why wouldn't you do it that way? Well, we got to the simplest, most reasonable conclusion. The early days, in the 50s, people were using bars over the 0, 1, 2, 3, 4, and 5. We had digits with like a not 0, not 1, not 2, not 3, not 4, and not 5. Honeywell in 1957 didn't use the letter A. They used B, C, D, E, F, and G. I don't know why that is. Pacific Data Systems in 1964 even made it more confusing. I think this came from maybe Roman numerals, I'm not sure, but they used L, C, A, S, M, and D. Why was that? But today we all use A, B, C, D, E, F, whether it's uppercase or lowercase, it really doesn't matter. So the nice thing is hexadecimal is like someone put a spell on you, and they can spell words. Dead beef is a very common number to fill, maybe when a computer crashes, to fill the memory with dead beef or something like that. But there's some words that people have made up using these 2-byte numbers, 16-bit value names that are rather common. So hexadecimal, 255 in hexadecimal. Remember, the columns are just like base 10. We have 10 to the 0 column for a 1. We have 16 to the 0, which also is a 1. 16 to the first, 16, 16 squared, and 16 cubed. 255 is the highest 1-byte number, and that is FF in hexadecimal. The highest 2-byte number in hexadecimal would be FFFF, which represents the number 65,535. So let's see how we convert a number such as a decimal number 1,234 into a hex number. First, we say how many 4,096s are going to be in there. well, in this case 0, since the number is lower than that, the integer number of 4,096's in 1,234 is 0. So we write a 0 in our left column. We take our number, 1,234, divided by 256, and there's at least 4 of those in there, but an integer number of 4. So we have to subtract out that integer number of 4. 4 times 256 is 1,024. When we subtract 1,024 from 1,234, we have 210. Then we take that number 210 and we say how many 16s are in there. We divide it by 16, we get 13. But remember, 13 is the letter D. So we put down D in our third column. And then we have to subtract out 13 times 16 is 208. So 210 minus 208 leaves us 2. We say how many 1's in there? Of course, it's the same number. 2 divided by 1 is 2. So the answer is 4D2. Sometimes we write 4D2 as 4 capital D 2 or 4 lowercase d 2. It's the same number. In C notation, the language C, if a number started with a 0 followed by 1 through 7, it was a octal number. If a number started with 0x, it was a clue that it was a hexadecimal number. As humans, we know that 4D2 is hexadecimal because there's a letter D in the middle of it, but sometimes it's not always that way. We could have the number 100, which would be equal to 256. But 100 hex isn't, you don't know if it's 100 decimal or 100 hex, so the 0x prefix would tell you that, and that's used in the C language and many other languages. So that's the story of hexadecimal.